Hi, what I'm going to do today is I'm going to introduce the introduction to integration by substitution. I will put up here several different examples. However, let's first review what we know by using the chain rule. If I would say y equals x squared plus 3 to the fifth power, I know dy dx, in other words, the derivative of this is equal to 5 times x squared plus 3 to the fourth power, 5 minus 1 is 4, times 2x, which is equal to 10x times x squared plus 3 raised to the fourth power. Okay, so now what I'm going to do now is, using what I know, I'm going to figure out the integral. I'm going to work backwards. And as I work backwards, I'm going to try now to integrate 10x times x squared plus 3 for dx. Now, if you're watching the video, that means you're a little confused with some of the shortcuts that your teachers may be doing. And they're perfectly legal. What I'm going to do is, I'm going to do it the long way, and if you see the shortcuts, if you see the easy arithmetic in there, that's great. And then you can do it that way and practice it, make sure you understand it. However, I'm going to assume with this video that you don't see it. So, like what I've done often, I am going to first pull out the constant. So I'm left with x squared plus 3 to the fourth power. Now, dx. If I want to integrate this, I'm not going to do x squared over 2. I'm not going to look at x squared plus 3 to the fifth power, because I need to work that chain rule in reverse in some way. And this is where integration by substitution comes in. Let's say u is equal to x squared plus 3. Then I can say du is equal to 2x dx. But wait a second, I don't have 2x. I just have x. So what I'm going to do is, I am going to, in my own mind, divide both sides by 2. Now I'm left with x dx is equal to 1/2 du. Now let's look what I have here one more time. If I copy this, and I'm going to copy it in order, 10 x squared plus 3 to the fourth power times x dx. Do I know what this piece is equal to? Sure I do. I let u equal it. So now what I'm going to say is 10 u to the fourth. Do I know what this is equal to? Sure I do. It's equal to half u. 1/2 du. Now, do I have a constant here again? Yes. So I'm going to pull that constant out again. So look what I have. 10 over 2 u to the fourth du. So now I have 5 integral of u to the fourth du, and let's integrate that. U to the fifth over 5 times 5 plus c, and I'm left with u to the fifth plus c, and u to the fifth we said in the beginning was, let's look at that again, x squared plus 3. Y is equal to x squared plus 3 to the fifth power plus c. Look what I have up here. All the way up here when we did it. y is equal to x squared plus 3 to the 5th power plus c. Because if I find the derivative of a constant, 2, 3, 4, 5, it ends up being 0 anyway. Let's do it again. What I'm going to do is put up here 2 or 3 separate examples, and we're going to practice it and look at it. Let's say I would say the integral of e to the cosine x sine x dx. Well, the first thing I'm going to do is, I don't know how to integrate it. So let's look at substitution. Let u equal cosine x. So du is equal to, derivative of cosine is negative sine x dx. And if I want to look at it and divide by -1, sine x dx is equal to negative du. Now let's go back to what I have right here. Do I know what cosine x is? Sure, u. Do I know what sine x dx is? Negative du. So now I'm going to work it out. E to the u cosine x. Sine x dx is negative du. And now if I pull out the constant, negative, e to the u du is equal to negative e to the u plus c. And what was u again? Cosine x. It's negative e to the cosine x plus c. I'm finished with this example. I'm going to do one more example. And then I'll let you work on your own. The only reason I like doing this example is because it gets you to work on what we know. Let's say I ask you to find the integral of tangent x dx. Tangent, let's look at this. Tangent, okay, tangent squared, no. Derivative of tangent secant squared, I don't have that. Wait a second, I have an identity. Let's look, do we know what tangent x is? For those of you who answered sine x over cosine x, you're right. So I can say tangent x is sine x over cosine x dx. Now let's look at what I have. If I turn around and say u is, well, before I do that, let me just rewrite it for you, the people who are watching this video. Can I say this is the same thing as 1 over cosine x times sine x dx? They mean the same thing. Well, if that's the case, let's work on what we know. Well, we know u is equal to cosine x. Well, if that's the case, du is equal to negative sine x dx. And like the previous example that I just did, I'm going to divide both sides by -1. So sine x dx is equal to negative du. Now what I'm going to do is, again, integration by substitution. I'm substituting in the information I know, and then I'm going to integrate. So look what I'm left with. 1 over u, sine x dx is right here, negative du. But wait a second, do I have a constant? Yes, I pull out that constant all over again. Negative 1 over u du. And what's the integral of 1 over u du? Log. So natural log of u plus c. But wait a second, what's u again? Cosine x. So negative log cosine x plus c is our integral. And with that, good luck while practicing integration by substitution.